Hey guys, I changed around the camera and mic setup. The old camera that I was using, the HDMI port actually went out, so it's a lot closer in than normal. Let me know if it looks fine, and then also let me know how the audio is. I guess until more people get here, I don't want to jump into the design like I did last time because it obviously takes some time for everyone to tune in. So I guess in the meanwhile, working fine, sweet. So I guess in the meantime, if we just want to do, if anyone has any like questions or anything, I can maybe answer those and give it like 5-10 minutes. Then we start the design. Um, Let me know if there's anything you want me to go over. If not, I guess we can jump in after the fact. Also, I hate one thing I didn't realize about live streaming is it's a super big delay between what I'm actually talking and when I'm able to see the comments of when you see the stream. It's like 10-15 seconds delayed. So it's kind of weird when I ask something, there's at least like a 10-second delay. I can change like the I forget what YouTube calls it. They have like an ultra low latency, which I guess if you're like doing video games, you can do, but it makes the quality really bad, so I don't really want to do that. So I guess we'll just kind of deal with this. But it does not seem like anyone has any like Q&A type questions. So if that is the case, I guess I can just kind of go into the gist of this project. So basically, the projects that we typically work on, they're pretty large to where most of the jobs we're doing take weeks at bare minimum to months. So they're pretty expensive, and we don't do usually a ton of them per year. So I thought it would be cool to have like as like a thank you or even like a yearly type thing, like a handout, like hey, we appreciate your business. And it would be cool if it's something that obviously we design in house, or also something that might be kind of neat to where they don't just look at it like most people's like thank you card and just throw it away. So what I came up with is a little like display for like a digital picture frame. It'll be based on this Winstar touchscreen display. It's a 3-ish inch display, I believe, somewhere in there. And they're super cool. I worked with them on a project we were doing recently. It has a touchscreen layer, it has a SPI interface, and it has a parallel bus interface. And it's pretty easy to communicate with, it's pretty easy to interface with. I don't think I will be using the touchscreen feature, but probably will add the driver in anyway. So it'll be a screen with the board, I guess, mounted somewhere behind it because I kind of want this to be fairly small. And on the back side, it'll have a single SD card or micro SD card, and the display will, whatever images are on the micro SD card, it will just play it as a slideshow. So what I'm thinking is do something like a Microtype logo, thank you for your whatever, some sort of little thank you thing like that, and just hand that out. And then when they see it, have like a little sheet with it and say, hey, thank you so much, blah, blah, blah. By the way, take out the SD card, throw whatever images you want on it, and then it will just display like a little digital picture frame. So obviously not super like useful or super involved, but I think it's kind of neat. And if we'll make it possible to reprogram it, I mean, I guess I could expose, because what I'm definitely thinking, because not only is this like a neat little thing to hand out and say thank you, it's also my thought about kind of just showing off like a board we design. So I'm thinking some sort of little 3D printed enclosure, but having probably the back of the board mostly exposed to where you can see like designed by Microtype, showing the stuff there. So yeah, I guess probably use a tag connect connector. So sure, could have that be exposed. Nice camera, sweet. I'm glad you like it. I literally set it up like a few days ago, after the HDMI went out, like I said. So, and what's also funny back to this, I was thinking also the USB port, the USB hub project, that would also probably be a really cool project to hand out, as well. So maybe that will work in place of this, but I still like the idea. Um, so in actual design wise, I'm just gonna go with the same STM32 that we did the original design with, solely because the code is already mostly there. It'll be able to be ported over pretty easily. Um, it'll have to be, I think we're using, hang on. So the STM is an F1 series, so that one is actually a, victim of the whole IC shortage. So it'll have to be like the F4 or F7, but it'll be the same pinout. So I'm just gonna base it on the F1 that we did this on, but then it should be swappable with the next series up, which is what I've noticed. The majority of the STMs in specific that are out of stock from the IC shortage are all the low level or low performance, and the high performance ones seem to still be in stock more. Hopefully it stays like that. If it doesn't, that's going to be a pain. All right, well, let me switch over. So again, I am gonna do this in KiCad 5.99. I figured that is probably, I'm not going to use it for any work stuff, solely because I like only using stable builds. But for all of this stuff, I figure it makes sense. So the first thing I am going to, has your email been down? I don't remember your username, but someone had mentioned that I hadn't replied to an email, but I had and sent it back. And I mentioned on YouTube, so maybe message me separately again or something. F4 seems plentiful. Yes, that's what I've noticed. F4 and F7s are still available, but a lot of the L series and F1s are out of stock everywhere, which, truth be told, I guess that makes sense, solely because the more expensive they are, the more likely not as many people buying them for, at least in any quantity. So that's at least the hope. Let me move this over here. So like I said, I'm just gonna swap over and use the exact same STM that I did beforehand and adjust the page size. I always start with a pretty big page and then move it over. So first thing, could either start with the microcontroller side or start with the touchscreen. I don't know why the KiCad 5.9, it starts with a super fine pitch grid every time. I don't know if that's some sort of configuration I have, but it's kind of weird, where it should just start with the 50 mil. I'm sure it's just a configuration. So I guess I'll start just solely with the STM and get all of its connections done. I do like definitely the look of KiCad, which is going to be KiCad 6, a lot better. It looks a lot more like they were changing the PCB new, the schematic layout side too. So ground, and then for power, so this is something I actually hadn't thought about. So the one nuisance with the screen is it's a super bright TFT display. but it takes, here, I will pull up the data sheet so I can show you what I'm talking about. Oh, what is the part number? I do not have the data sheet. 1 second. Well, anyway, while I pull this up, so basically the backlight is in series, all the LEDs, instead of parallel. So it takes like, I think 10-ish volts for it to be powered. So the voltage supply is going to be kind of a pain. Either we start with 12 volts, buck it down to 3v3, or we start with like a 5-volt USB and then boost it to 12. I'm thinking probably the latter. I think that makes more sense. But here, let me get this. It's really hard to pull stuff up while talking. I guess I'm not as good at multitasking as I thought. And actually, somehow the part number that I have on here is slightly wrong. This is the, I believe the one that, yeah, the one I am going to use is the TFT display. The part number that is on there is like a lower power TFT. So the actual one, instead of ETLA, it is JSYA. JSY. AJDNT. Okay. And unfortunately, I don't think that this is JLC, Ping Play, CMP, 15K plus. Yeah, I would doubt that. So actually for the project that this is based on, and not to say that you're not right, I'm just saying them and what else, whatever the parts supplier that JLC uses, they like to over advertise, because I got a couple quotes from a parts procurement company near here for this. This part is like a $9 microcontroller, and I got quoted for like a quantity of 50 and up was the minimum order. It was like 35 bucks. So there's so much price gouging going on, which is a shame. But unfortunately, it's not going to change anytime soon. So yeah, here's the backlight circuit. So the forward voltage has a maximum of 10.5 volts. So we will have to have something that can buck it up to at least 10.5. So I am thinking we take in a 5-volt supply, maybe type C or micro, one of the two. So take in 5 volts, then we would probably just use a linear regulator to drop it down to 3v3, because I don't see this drawing any power whatsoever. And then use a switching boost constant current LED driver, and that will power the backlight. Will this be uploaded? Yes, I act like I've done a lot of these. The one live stream I did, I uploaded it. I don't see why I wouldn't. So yes, it will be on YouTube permanently. So anyway, let's get the core circuitry for the STM handled. Obviously, we need our oscillator. I'm just gonna go with a 12 megahertz. You can obviously clock it at whatever, and then whatever prescaler value you use. Not super important. I always like to kind of use a lower crystal if possible, rather than something higher, just to keep some of the noise down. And noise, I mean like EMC wise. So here, and one thing I don't know if I've talked about, at least in a while, all of my library parts are mapped 1-to-1 with a manufacturer's part number. So when I search for like a resistor, it's mapped to a physical part number. So it makes creating the BOM really easy at the expense of making the schematic creation take a little longer in case you have to make some parts. So, and I use, and this is just standard for STMs, I use a 470 series resistor on the oscillator side, on the out side. And this technically you want to check with an oscilloscope to make sure, I forget the term they call it, but you'll see instead of your nice square wave from the oscillator, it will like clip. If there's too much current going through there, it basically saturates it. And I've found with virtually every STM that 470 works. You'll see people, they don't do that. Like with the Atmegas, obviously, people don't do that. Arduinos don't do it. But with higher performance micros and for like USB hubs and whatnot, it's recommended. And if nothing else, you can just jump it with a or short it with a 0 ohm resistor and just bypass it. So this is a 4-pin crystal. Pins 2 and 4 are tied to ground, and then 1 and 3 are tied directly across the crystal leads. And then we need our parallel capacitors, which are based on the capacitance of the crystal. And why are my don't know why that's not coming up. There we go. Don't know why that didn't come up the first time. And this is another thing that should be tested with your parasitics on your trace. Again, 10 picofarad based on, this has a 10 picofarad. What's the term? I'm forgetting it right now. The term with a crystal for the stray, what they're assuming the stray capacitance is. Well, anyway, 10 picofarad tends to work with this. Again, that's something that you should test in your designs. I've never had an issue with it, but if your layout is a little bit goofy, it can affect it. Is there a reason you don't use sheets in your design? Oh, sure. Yeah, I use hierarchical sheets all the time. This one, I don't think we're gonna need it. I mean, we have a microcontroller, a power circuit, a display, and an SD card. I think that lends itself fine to just having a single page sheet. I want to do a video. Actually, yeah, I had mentioned this in Discord a while ago. The USB hub definitely will do. I'll go into depth a little bit more on how I do hierarchical sheets. I've kind of changed it around recently. Still getting used to the non-lazy selection or whatever they call it with the KiCad 6. But yes, definitely we'll have some more videos on hierarchical sheets. So there is our crystal circuitry. And next we need to tie our boot pin down to ground, and that just sets the state of the default power up. I would sometimes have a jumper here just in case we wanted to change the boot state, but in like all the designs we have ever done with a STM32, we've never needed it. So now I just tie it straight to ground with a 10K, and it seems to work fine. Something I haven't mentioned either, I don't do really any embedded programming these days. We have some programmers who do that. I got started with programming. I actually did a lot of desktop stuff way before I did any electronics, but I really don't like doing embedded anymore. So when it comes to intricacies with like architecture from address buses and all the peripherals, that is not my strong suit. I do a decent bit of desktop programming still, but that's about it. Is the display resolution? Ooh, I believe so. That sounds right. I don't really remember. I feel like it might be a little higher res, but no, it's not obviously crazy. Oh gosh. So the eighth letter. What is the eighth letter? 1, 2, 3, 4, 5, 6, 7, 8. So it's A. Oh. A. Oh, it's even worse. 128 by 160. So yeah, these are gonna be pretty bad images. That seems wrong. From my experience with this, it was decent. I'm gonna go with, unless I counted wrong. I did. It's offset by 1 because the first one they fill with Winstar for whatever reason. So 1, 2, 3, 4, 5, 6. So it's J. What is J? 240 by 230. Yeah, 240 by 320. So yeah, exactly what you said. Since it's such a small screen, it does actually look better than you would expect for that low res. So now the reset pin, either can do just a cap. Oh, don't want to do that. Either do just a cap to ground to help with it not resetting, or you can do that and a pull-up resistor. If it's in a noisy environment, I will always go with both. If it's not something that's going to have a ton of switching noise, or I'm not really expecting it to have a lot of interference, then I will typically just leave it with the capacitor. That's something you hear about a lot, that people will have like their board resetting because the reset pin goes low. I've never had that happen, but if you want, you can put a pull up here. But a capacitor is probably fine. Okay, so there is all of our circuitry. Assuming I didn't mess anything up. Out, oscillator, ground, 10 peak. Yes, that looks good. Okay. Now for the voltage side, input rather. Batteries not going to be used. Analog, there's not going to be any analog on this, so I don't see an issue with just tying it to the main power rail. And I guess what we can do to keep it a little bit cleaner is let's label these. So VDA. Okay, the copy paste works pretty well. And yes, I know I could have hit insert. I didn't realize I was starting from the wrong side though. I actually did not know that until a video I did a little while ago and someone told me, and I had been typing out large pinouts by hand every time, so I'm very grateful. So totally don't rip the flex PCB. Yes, I will I'll do my best. Especially if it drops on the floor too. What's funny is actually this isn't the exact display. I only have one of those out back. We got some samples. This one actually doesn't go into an FPC connector. This one solders. I don't know if you can see that. This one goes and solders straight on the PCB, which for something where you're just making a few would be an absolute nightmare. So the J version, the JSY, that one goes with a FPC connector, which is a heck of a lot easier to install. So there's all of our power rails, and now I will take, oh, that is not what I wanted. That's weird. In KiCad, whatever this is, 599, it doesn't pull up the plus 3v3 when you type in 3v3 anymore. Maybe because I didn't do plus, not really sure. So For STM32s, they typically have power pairs, so they'll have a VCC, or they call VDD, with each ground. So you want to have at least one decoupling cap for each. For something like this, just because some of the data lines are kind of high speed, so there will be some switching noise, I tend to put two caps per pair. So, and I'm doing this with an 0402 standard size. So what I will do is tie two. See, that's one thing I'm not a huge fan of with KiCad 6. You can't just do that quick little duplicating. You have to physically copy and paste it. I don't know how big of a difference it makes, but it seems kind of annoying. And I am just going to do it like this, and then, yeah, that's going to take some getting used to, because that is completely different than how KiCad 5 does it. So now we need to duplicate. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And that would have been a heck of a lot easier had I copied the little wire piece. I don't know why, but I always like having at least some sort of wire between parts and not having it connect straight to whatever it's going to. I don't think it matters in the least, or I know it doesn't matter in the least, but it's something I've always done. Oh yeah, I don't like that. I liked being able to do that lazy selection where you could just hover over it and duplicate it, but I guess at least this is now consistent with the PCB side, which I am all for, even if I'm not as big of a fan of how it does it, as long as we can get some more consistency between the two. And notice I did 1 mics for all of these instead of 0.1s or 0.1 and 1s. And this is something I have done a lot of simulation stuff with lately, and I'm working on a pretty in-depth like kind of series on both the simulation side, and I want to do some real-world testing with it with oscilloscope, with my oscilloscope and spectrum analyzer, just kind of going over the different methodologies of decoupling. It is, well, that doesn't look good. There's a lot of differing opinions out there with this, whether you should do decades apart. I used to always do decades apart, and I don't think it's inherently wrong. I just think that doing it with the smallest package size, biggest capacitance that meets your voltage requirements kind of is going to be the best of both worlds, but I won't get into that too much here. And one thing I've noticed a lot of people miss with STM32s is if you look at the hardware recommendations right here, you'll notice that they always recommend your, oh, they actually do recommend 2 per pair. That's funny. And then they always will recommend a 4.7 mic. So that's really common that you should do, whether it's exactly 4.7 or something potentially a little bit bigger. It helps a lot because, especially if you sprinkle it around on the extremities of your port here, it helps lower the impedance of some of the lower frequencies quite a bit, just because there's a much larger capacitance near it. They recommend the 4.7 from what I've seen too, and like you doing spice simulations, a 22 microfarad works really well. But for STMs, that's what they say, and that's what I've usually done. So, and they don't recommend a specific pin typically. Oh, never mind. VDD3. So that is why it needs to be on VDD3. Okay, that looks really bad, but I don't feel like putting all those over. So now all of these are tied straight to the decoupling network, and we can put that right there. So now we have, I believe, all required circuitry for this. Other than, I guess we can wrap it up and have programming header. So what I've started doing maybe like a year ago is instead of just using like a generic 6-pin connector for the tag connects, I use a standardized symbol part that has references for what should go where. So then all of my STM related boards use the same breakout on the tag connect. And because before I would just kind of randomly do it and just throw them kind of wherever. But then you run into the whole, you have no idea which pinout you used for a specific board, and you have to make a bunch of little breakout connectors. So this kind of solves that. And now we need our, this doesn't use a, mostly this just uses the SWDIO, and based on where they have it, that is PA 13 and 14. SWDIO. Hello? Am I missing something here? I don't know why it's not placing the label. Maybe I have to have this out. Yeah, it is kind of nice messing with KiCad 6 here where it's not actually for a true work project. Anyone got any idea where the, oh. Sure, I guess that makes sense. I have no idea why I was going over there. I'm guessing it has something to do with the whole new selection methodology. But that kind of seems like a pain. Okay, SWDIO is on PA 13, and then SW clock is below it. Okay, yeah, this is gonna take me some getting used to. Okay, clock, and then we also need a connection to reset. So ST. Okay, why is it doing that? Yeah, does anyone know why it's spawning that completely over there? I haven't selected anything over there since I placed that part. If that's not a bug, then that's just kind of annoying. I don't really know why that would be. And this has a reset line, so I'm gonna title this MCU or STM reset. Really looks like a bug. Yeah, that's what I'm going with. I don't see how in the world that makes sense, but I'm sure people who have used this version more than me can chime in. One funny thing, again, this is on my second stream, a lot less comments so far. Either that means I'm doing a really good job and everyone's intrigued, or people are like, what in the world is he doing? And just don't have any comments. Hopefully it's the former. Okay, tie reset in, tie IO, and clock. Alright, so there's all of the core circuitry for the STM, and we can just throw it over here. So yeah, I don't know, do you guys want me to kind of go over how, if I were to be doing this in hierarchical sheets, how I would do it? If this was mine doing just for like a personal project like I'm doing it, I don't think I would, but I guess it could lend itself to doing that way, so let me know I can do it either way. Resetting the program fixed it. Okay, so it is a bug. It's not just me. Stream is great so far. Awesome. Glad to hear it. I definitely like doing these streams. I wouldn't say more than the videos, but it takes a really long time to edit videos, and a stream, I just kind of do it and it's done. How is KiCad 6 verse 5? Can someone, I'm sure you guys have seen that really good post. I am drinking crystal clear water. Thank you very much. Unfortunately. That's funny. But yeah, someone posted a really in-depth comparison. Let me see if I can find it. And it went into like every single feature that, yeah, I found it. Tech explorations. Can I post a link on the stream? Yes, there. Check that out. I don't really know anything about his website, but man, he did like a fantastic job. And it's funny, I've never really done like true like KiCad specific videos. I was thinking, man, it'd be so cool, like maybe KiCad 5 comes out, do a video of my favorite features, and then I see that and it's like, I'm not gonna be able to beat that. He goes into really good detail, so I would highly recommend reading it. So one person for hierarchical sheets, since nobody else said anything, I guess that means we're doing hierarchical sheets. I don't know what they look like on here. Oh, they changed it. And this is probably going to be bad. Oh boy. I don't know if I'm going to be doing them. I have no idea how it works in here. Why can't I just, like, drag it? Yeah, there's something goofy with this. Maybe I got a bad nightly build because everything keeps going over to this spot. And I can't, like, drag it. Unless is it going somewhere else? Am I missing something again here? I have no idea, guys. Let me try. Yeah, using nightly is always a risk. Now you see why I don't use these for actual client jobs. I don't think that would be a good excuse to tell them. Dang. Oh, wait. Oh, you can't drag it up to the left. Alrighty. The more you know. Okay. So, the way I have been doing hierarchical sheets, so I would name this one STM32. Oh, and they actually don't do that little randomized schematic names. And we can keep this, I guess, the same. And put this here. And now let's copy and paste all of this in here. So I have seen people do, I've been building for master, I have no issues. Yeah, I guess it just depends when you grab it. So one of my biggest pet peeves with hierarchical sheets is people will do it in such a way that it makes it so much more complicated than it has to be. So my whole goal with them is to abstract all like the nitty gritty or like the inner workings, but exposing every single thing that is important to where you can look at the top level. And this is the single biggest key. You can look at the top level. So you can look at here, and without knowing all the nitty gritty, you can tell with 100% certainty what's connected where and what is the overall function of it. So, and that means never, ever, ever any connectors on the inside of a sheet, because you can't look at a top level and find out where all the connectors are if you hide them in here. So tag connect has to go out here, and everything else can stay. So what I would do is basically get rid of my 3v3, and I would have label, I think that's the right one, yes. So And I typically will name these not with the voltage because the voltage will be shown from the outer sheet, but it doesn't affect me. Like, I don't care too strongly either way. And then on the ground side, do ground. And yeah, you can change input outputs. That always takes so much time, and I always end up forgetting them at some point, and it ends up being just as messy as if I hadn't before. So I tend to just keep it. And then my rule also is never have a power net that isn't connected to the outside. So I will not use any global power. Would you have VCC and ground going into... Man, you're jumping the gun. That's literally... That's kind of funny timing, though. That's literally what I was just saying. So yes, the power always goes into it. Because again, when I do a hierarchical sheet, my absolute goal is you can tell exactly what goes in at every given point, and you don't ever have to make an assumption. The other big thing is, since, like I said, I'm not doing the programming, my goal is for our programmers to be able to just look at top level and see what's connected to where. And that's where what I do here is something I have never seen. I say never, like I've looked at so many other people's hierarchical sheets, but I've never seen someone do. So typically, if you're doing a hierarchical sheet, what you see a lot of people do is they will break out this pin and name it SWDIO, and then have SWDIO out here. What's the issue with that? Now, if you're trying to program it, you have no idea where that is, especially with a micro like this that has remappable peripherals. You could be one of 3 pins, not specifically with SWDIO, but if it's like SPI 0. So what I will do instead is every pin that leaves the hierarchical sheet is referenced, that is not the right one, is referenced to the actual pin name. So PA13, PA13, and then, yeah, I could have done insert again. I forgot at that time. So PA13, PA14, we can get rid of those. And then on here, we will do not STM reset. We do N reset because it is a exact copy of what is on the schematic itself. So now everything coming and going from major connections are going to be exposed on the outer sheet, with the only things that live... Where'd that come from? Somehow that got moved. But the only things that live in here are the internal workings, which you don't need to see a capacitor, a decoupling array to know what's going on from the upper level. You don't have to know what's going on with the crystal, all of that stuff. So now we go up here, import hierarchical sheet pin. Whoa. Oh gosh. Okay. I am really, really hoping one of the most annoying things, and I don't think you still can. Okay, so if anyone wants to make a suggestion for me to any of the KiCad developers, let me select a group of hierarchical sheet pins and move them. Oh, okay, that's a little bit better. I would still like, because what you'll see is I'll have an entire port of pins here, and if you want to resize it, you have to move them all one by one. I guess selecting them like that's a bit better, but still kind of a pain. So we throw, and okay, cool. So now you can have them on the top and bottom. You couldn't have that in KiCad 5. So now we throw VDD and ground, and then what's nice about doing the hierarchical sheets is it gives you much greater ability, shift drag from left to right. Oh my gosh. That is amazing. So please, please tell me that that's not something that's been in KiCad 5, and I could have done that this whole time. I'm hoping that's something new here. If not, I'm going to be really disappointed in myself. But like I said, I have learned probably more about KiCad from making supposedly instructional videos and people telling me different ways to do it. But that's kind of the whole goal with this. Just tested it, so it's not in KiCad 5. Fantastic. That makes me feel a lot better about the probably hours I have spent having to do them all one by one. So now clock was PA14. So clock and DIO, oh gosh. DIO is, double check, 13. And I don't know how I managed to get both of those a different length. And then, so now here, I am totally fine with going back to the STM NRST because that is now out in your global sheet and you want to differentiate it from the LCD's reset pin. So those I keep separate. Whoops. So now we have our STM. Oh, we can add 3v3 plus 3v. So yeah, I guess you have to do the plus 3v3. So now we have 3v3 coming in, and then we can have our ground coming in the bottom. So like I was saying, the biggest thing I like about this is now you know this is an STM32. It takes in 3v3 and ground. It has DIO and clock to PA 13 and 14 respectively, and the reset is connected to the NRST. So then what's also nice is when you go to review to make sure you don't mess anything up, when you go in here, the first check you do is just make sure PA 13 is mapped to PA 13. And then on the outside, which is typically done from the programmer's perspective, they check to make sure DIO should be to PA 13 and 14 with the clock. So that's how I tend to do the hierarchical sheets. And what I also will do, oh, they changed the font that it types in there. Go figure. Oh, that is very thin. So then what I'll also do sometimes is add nice bulky letters here. Oh, you can change this now. That's another thing I don't think you could do on the other. Maybe. I actually don't know if I've given that much thought in the past. Okay, so there's our STM32. Do you know if KiCad allows? Oh, absolutely, it lets you resave them. I'm glad you mentioned that. That's one of the other really nice things about hierarchical sheets. And Sparky and VA, he posts in the Discord quite a bit. Me and him working on some projects, we do that quite a bit. Like he does a lot of work with motor drives, so he'll have a hierarchical sheet with a motor driver, and then if I'm incorporating it into something else, I literally can just take that sheet and use it in a different project, and it imports directly. So that's really nice with hierarchical sheets, and why for more complex projects they're really helpful. Okay, so now do you guys want to do the voltage side, the input side, or the touch screen, or the what else? The micro SD card. Which one do you want to go to next? I don't really have a preference. Boost. We got 1 vote for boost. Of course, the more exciting part. Oh, SD card. We got a competition going. At least more than one person made a suggestion this time. Yeah, power. Okay, so I guess we'll do power. We can either start from the input side or just assume, okay, yes, everyone is going with power. So I guess we can start with the boost side and then worry about the true input after, because obviously the boost is way more exciting. So this will go into how I search for parts too on let me reorganize my screen over here. Okay. So this will go over kind of how I search for parts too on DigiKey. So we need to figure out the specs for the boost that we need. So, oh, and also plug for Discord. If you haven't joined it, please do. Let me grab you a link. Actually, no, there's a link in the description of the video. If you haven't joined already, please do. So for the, does the STM use a QSPI? I'm pretty sure it has a QSPI interface. I am not going to be using that. I am going to be using, they have a parallel interface built into this. They call it the FSMC, which is just like the 8800 or 8080 parallel interface, which is just data stream back and forth. The screen does do SPI, but kind of if you have the ability to natively in hardware use a parallel interface. Oh, for the SD card. Yeah, that probably makes more sense. Both make sense because the touchscreen does work on a SPI also. Yeah, I'll definitely be using SPI for the SD card. Okay, so it needs to be able to boost to at least power up to 11 volts ish, and then current 100 milliamps. And I reached out to Winstar about this, and it's kind of ambiguous. Is it 100 across each or kind of shared? It is 100 across each, so it'll be two outputs with 100 milliamps each. And one thing that kind of stinks, I don't know how easy it is to get Winstar displays like just off the shelf like this. From that project we did, I have a sales contact who I can get like buy just sample quantities. I'll post this on GitHub. If anyone's interested in doing this, I'll see what I can do talking to him, and if I can find a way to maybe get some of these or have them sell them to where you can use them in a small quantity. They're super cool. I really like them. Real low power. They're pretty inexpensive. And they work great. Okay, yeah, Buck got distracted there. Okay, so LED driver, and this will come up with a PMIC, so power management IC category. And get rid of my search because that always just bugs me once I get into the right selection. So first is always cut tape, and then in stock. In stock is super important with the IC shortage right now. But it doesn't even really matter because I could design a board right now, and when I go to order it in like 3 weeks, it'll be out of stock. So you just kind of do your best. So it needs to be a boost, so we know it has to be a switcher, power switch. They use weird nomenclature. I'm pretty sure it's anything other than linear. They all classify kind of different. And then internal switch doesn't matter. Number of outputs, we are definitely going to want one that can do at least 2. I don't really care how many. Our input supply is going to be 5 volts. So that's the minimum supply. Wrong way. Do it from 0 to 5 volts, and then let's see what that limits it down to. And output, we need it to be able to go, that's kind of a pain to narrow down, so let's do output per channel, and this we need to be at least 100 milliamps, and since this is directly related to how bright the display will be, I don't really care if it's right at 100 because we can always limit it. Dimming, I don't really care. Frequency, don't really care. That all looks good. So now I typically search by price and then do some sort of quantity just to get a more realistic price. And look at all the BGAs. That is fantastic. So now looking at the first spec, it can run off of 2.5 to 40. It is, oh, one thing. We need to make sure we are doing it with a boost. It can be a boost or a buck boost. They have charge. I was gonna say they only have 5. I didn't think there were many charge pump LED drivers. So we have 4 outputs. It can do 4.5 volts. Voltage output is 60. Good luck. Sweet. Yeah, I appreciate you tuning in. I'm probably gonna do some at different times just because I know anywhere other than I guess west of me, and I'm on the east coast of the country, and Eastern time is probably gonna be late for this stream, but can change it up. Okay, so those look like they would work. Diodes Inc. I'd like to see if there's maybe a TI, just because they're usually a lot easier to design for. 1 a.m. right now, yeah. That's kind of the bummer of it. Though I did do a poll and people like this time more. Maybe I'll do another now that there's more on Discord. So that output 6 to 45. So this TI looks promising. 120 milliamps per channel. It has an internal switch, which is helpful. 3 outputs, so only 1 extra. 4.5 volts. Boost up to 45. Adjustable frequency, which is nice. PWM, automotive, and backlight. There we go. So I am thinking that this is a winner. So let's potentially look at that. My main role is procurement. STM is at 26 plus weeks now. Yeah, it's awful. Not to go too off topic, but yeah, I mean, this is becoming like Microcontroller. This is becoming like a nightmare. Like, I am getting calls like weekly from former clients who can't get parts in anymore, and it's like a disaster because you can't even design around it because you have no idea how or which one's going to go out of stock. And I know STM's got it worse than anyone else because I guess they had like a strike a while back. So if we limit it to just STM32s with only parts that are active, only cut tape, there are 345 parts total. If we go to God, that has gotten bad. So what is that? Mind my terrible basic math here. Yeah, that's bad. So 40% of all STM32s are in stock. It's like that's awful. And from what I've been hearing, people are saying it's not going to get any better until 2022 because manufacturing should get better this year, but there's so many on back ordered that it's going to take them the rest of the year to deliver. So I just hope we get some sort of relief. So anyway, back to this. It's because of some, yeah, it's that, yes, the semiconductor shortage as a whole from COVID and everything, but STM themselves had I guess like a strike in France that tied it up too. Can you talk about library management? Yeah, I've done a couple of videos. I don't want to get too deep in the weeds, but I can kind of show gist of it for this one. So now that we have a potential part picked out, now I just kind of go through and see, honestly, make sure that there's not a ridiculous amount of external parts that make it inconvenient. So we have our input, goes across our inductor. We've got our switch node, output diode, that adjusts. Don't know what the feedback's doing here because it's constant current. Oh, that's to regulate the switcher, obviously. Our 4 outputs, we can set probably our nominal current with that. PWM our brightness, turn it on and off, and then we have a fault output with a pull down. It has, I guess, an internal linear regulator for something inside our frequency set. Spread spectrum for lower EMI. Yeah, that's helpful sometimes. Sometimes it makes it worse because now instead of focusing it at a single peak, which you can design a filter for, it will then spread it out over a broadband, and then you will get harmonics across a really large spectrum. So, yeah, that's helpful sometimes. But yeah, I think this works. What are the difference? Um, I have no idea what the difference is between. So what? Oh, right here. 3 channels, 4 channels, automatic current derating support. No idea what that means. Oh, it can drive an external FET, I guess. So then which one do I have here? Because it said no external switch. Um, Power line FET control. So it does say that it has it. Kind of confused now. Let me see the references. Maybe power line. And that's the only place that it mentions it. Outstanding. I honestly have absolutely no idea what that means. I don't know what the difference between them really are. They only show a general schematic. But unfortunately, that does kind of worry me because there's obviously something different between the two. Okay, they do an example application with the 8867. I don't want to spend too much time kind of figuring it out. Maybe I'll check later, but I think this is good enough for me. It seemed to start a campfire. We had 20 plus parts. Yeah, and that's, yeah, people securing 18 months. Yeah, that's what's kind of killed it for a design shop like me. It makes it a lot harder to get smaller quantities, but you do what you got to do. Okay, so yeah, let's build this part. So for symbols, like I said, I tie it 1-to-1 with a manufacturer's part. And someone mentioned on the last video I did that there's like some plugins that you can extract from a table to add all the pinouts. I looked into it a little bit. It didn't seem like there was like fantastic support for it, but maybe I'll look into that another time because like doing pinouts with why is it not showing in my libraries? Oh, maybe I haven't added them here. Snap EDA. Yeah, that's probably smart. Instead of making it on stream, I like that idea. Do they have it on it? Doesn't show it on. It doesn't show it on the Ultra Library, and I'll search on Snap. I never, and this I guess goes to the point of whoever had asked about the library management. I never ever will use an external library part. Everything we do is designed and part not available. So I guess I am still making it just because I don't want to risk having a part go bad or the symbol be wrong and it's not something that we built. So that is really weird. It is not showing any library, even though I've been grabbing them from it. I don't understand. I'm guessing that's probably another bug. Not really sure. Okay, let me try adding them again. Oh, is this because I can't add it to a... That's exactly it. I can't add it to a KiCad 5 library, so I'm gonna have to make a new one for this project, and that's where I will put all of the new libraries. I even made one for it. I even had it all set up. I actually have a library on GitHub with some of the stuff that I've done in videos. It has like 5 parts on it, I think, but at least it has something. So, that's funny. They don't use the TPS nomenclature typically. You'll see TI use that for everything. Okay, so the only thing I'll mention with how we do parts is I'll do a field for ID, and then I'll do a field for manufacturer's part. Value is the actual manufacturer's part number, and then the ID is what is actually visible, and it'll be what just represents it in the schematic in the like data sheet. So if you look at it, you can pretty quickly see what it is. And this actually goes out to the C. And then you should give the Amp Hour podcast interviewing. Yeah, that'd be pretty cool. I mean, it might be a little odd because... Oh, a listen. Okay, got it. I was really confused. I thought you were suggesting me to, like, interview him. I'm like, I think you overestimate how many people watch my videos. And then manufacturer, TI, and then I do the description here. So now if you search for any of these, it'll come up. And that's, oh, and this is hidden and the value is hidden. Her, very cool. Yeah, like I said, I have no idea. I've never used Snap EDA, so I don't really... I take that back. Snap EDA absolutely for 3D models. 3D models I will absolutely get elsewhere, because if that's wrong, it doesn't really affect me. So now we will make greetings from Germany. Awesome. Microtype is awesome. Fantastic. Glad you're here. Okay, so pin 1. This part kind of sucks, because it's going to take up a decent bit of time on the stream, which is why, Daniel, I'm glad you mentioned Snap EDA, but they do not have this, so I'll try to do this as quick as possible. And I didn't want to have parts pre-picked out, because I wanted to kind of go over my entire process of like how I do it, but maybe for the future I should, because this is kind of a pain. So I guess while I'm doing this, if anyone has any like general questions or anything they want me to answer, let me know. If not, you can just hear my incredibly loud keyboard go to town, which I know some people have asked about what it is. It's a Philco Ninja Magitouch. Fantastic keyboard. Expensive, but I think it's absolutely worth it. I mean, probably isn't, because it just uses the same blue switches as everything else, but it looks good. Okay, 12 is out for... It's a weird pin name. Out for and ground. That seems kind of odd. $13 is out. 3. Let me do this. 17, 18. Favorite video game to play. So when I was younger, I used to be, I guess, so I started, the first game I ever really got into was RuneScape, which me and Daniel were talking about this a while ago. So I played that when I was younger. Then I got into Call of Duty in like middle and high school, and was beyond obsessed. Like, it's unbelievable that I even made it to college with how much I played. But it really consumed most of my life. So ever since then, I kind of forced myself to not really get into video games. So I really don't play that much. I play War Thunder. War Thunder is probably the game I play the most. But really, uh, I don't play video games. It's bad news if I do. And I get migraines kind of bad, so I try not to. I'm not going to do all the electrical types. That's just going to take way more time than it should. Maybe just do those. You play RuneScape? Yeah, RuneScape will always be pretty, um, really, really special to me because that is what got me into programming. It's what got me into electronics indirectly, but programming directly because I was a part of, and still kind of am, a part of a very successful macroing community where you like, cheat, bot. Everyone hates that part of the game. But I think what a lot of people don't realize about the macroing side is you learn a lot, and that's where I learned everything I know about programming. So it really like jump started my career into this. So I don't really play anymore, but I still watch videos and stuff now and then. Why do I not have an LDO pin? Am I missing LDO? Oh, I already put LDO. F set. Which country do you play in War Thunder? Ooh, tough. Okay, so I'm pretty decent. I have like I think a 2 to 1 KD on most planes. I hate jets. I do everything in my power to not play jets. I think that's just not what War Thunder was made for. Germany is by far my best country, but America I'm decent at with the wait 1 second. Okay, yeah, that's good. Yes, now I need sync. P47s, P51s. I like the Russian yaks a lot, but definitely Germany is what I'm best at. I don't do any tanks anymore. Yeah, so definitely in the future, I'm gonna do my best to have parts pre-created because this I don't think is overly enjoyable for anyone because I'm not actually like accomplishing anything here, but almost done, so it won't be too much longer. Uh, Fault, grounds, and now another thing for library management, and this is something I've started doing somewhat recently, is I don't, unless there's just a crap ton of ground pins, I try not to hide any of them because it makes when you're doing the layout a little bit more confusing because you don't realize where the pins are actually from, which is obviously kind of important. So NC, we can hide there. Feedback goes here. Switch node. And now VN, so we have 2 VNs and then a second NC. Not much tanks. I started playing tanks and I liked it because it's a lot more strategy than like pure like what in like the Call of Duty days you would say like gun skill. But I don't know. Planes are fun. And honestly, I kind of like the fact that you can like just chill until you get to the actual fight because I don't do arcade. I do what used to be called historical battles. I forget what they changed it to. Okay, let me make sure this is right. VN, LDO. ASET. And what I do with stuff like this is I'm typically just going off of what they're showing here. Just because why reinvent the wheel? They already have a setup which works pretty well. I said, okay, looks good enough for me. I'll probably go and double check. So put this here, fill it with body background, and then roughly make sure everything is centered. They want the switch node over here, I guess, so the inductor can go there. That works for me. All right. Okay. Got that. Copy that. Okay, sweet. So now for here, and what I like doing, even if it's going to be a hierarchical sheet, I typically will start it out here just because that way I can know what connections are going to be made beforehand. And I missed the feedback pin. Dang it. All right. So it auto updates. I thought one of the things with KiCad 6 was this was a cached symbol like it was on the PCB, but it auto updated when I adjusted that. Anyone know why that is? Because that's the exact opposite of how the PCB new is, and I thought that was the whole goal with this. Maybe I was wrong. So we can take our 5 volts in, and on a buck converter, it's obvious. On a boost converter, since we have the inductor side, the inductor stage on the input, it's filtered with that inductor. So we don't have to worry near as much about filtering the input side for EMI. It's the output side, but the output side goes to a screen and it goes to peripherals near the board. So EMI typically with a buck with a boost isn't as big of an issue anyway. The big issue with a buck converter is the fact that it noisies. It makes your input side noisy, which then goes out on your power connector and can radiate off of there. So that's why I usually have to do more filtering for bucks, but you still can for boost, and it's still a good idea. So for TI, it's usually how do I get rid of this? There we go. I usually will start with their reference design, just because, again, why reinvent the wheel? It's a good place to start. And they might have even a chart with some recommended inductor values based on the frequency. Obviously, the inductor is based the inductor value is based virtually entirely on the switching frequency. It's not overly related on the actual IC or the actual buck or boost you're using. So this actually seems pretty applicable because they're doing 100 milliamps in 4 strings. We're doing 100 milliamps in 2, so the outer current is about right. 400 kilohertz is pretty good. It's still low enough to be pretty efficient, but it's not so high to where you are gonna have to worry about EMI that much. So I am thinking, again, kind of for the sake of keeping the time kind of short, is probably just basing it mostly on this instead of doing all the calculations, because the calculations, obviously, you can just base it on here. So I think that's what I'm going to do. What inductor value? Jeez, that's a beast. That is a lot bigger than I would have thought. And I don't think I have one in my library that large right now, or that specific size. So this, I'll just go ahead and use a generic inductor. So we have our switch node, which this is obviously our noisiest node on the entire switcher, because this is where the internal FET is switching on and off to boost the voltage. And then this ties straight into our VN. They show their input cap on this side tied to ground. I don't think I'm going to do it that way. I think I would rather have them tied over here, just because it makes it a little bit cleaner not having to have voltage everywhere, or not having to have grounds everywhere, rather. So they're using 2 10 mics and a 33 mic electrolytic for the input side, and they're using the exact same on the output side. One thing you see a lot with these is when they show their reference designs, they don't give a crap about really EMI. So this is basically what they're saying is the actual capacitance needed for it to be stable. They are not including any radiated noise or any of the high frequency garbage that will be present, because with a 10 mic, you're looking at what? At 50 volts, probably an 805 to a 1206. So you're going to have a lot of inductance in those leads. So even if you go with these values for the bulk capacitance, you would absolutely need to have some, I'm using 0402, so I would throw in some 0402s, both on the input side and the output side, maybe just one on the input side, maybe two on the output, just to help filter some of that. Pretty much required if you're going to do any EMI testing, especially on a buck. A boost is a little bit better. And they do the 33 mic electrolytic solely to make sure that it's damped, because with this inductor, you're going to have a resonance peak where it is going to spike like crazy unless you have something dampening it. You don't have to use an electrolytic. You could use a, I don't know, a couple more 10 mics, but you would have to put a resistor in series or just use an electrolytic like they have. Either or should work. So our voltage doesn't have to be as high because we're only boosting it to like 12-ish volts. So I have an 805 can be a 50 volts. Greetings from Brazil. Awesome. Glad you made it. Just in time. So 50 volts, 10 mics at an 805. That sounds fantastic for me. It is crazy how far ceramics have come. I mean, not that I've been doing this for eons like I know some people, but even just in the time that I have been, I swear like every couple years it seems like you're able to get higher capacitances in smaller packages, which is really cool. So now that looks like crap. I like to have these centered with wherever they're going. Obviously, it doesn't matter at all, but I think it looks a little better. So we have our input caps here, and then we can add an electrolytic. I don't know, electrolytic. I don't know if I have exactly a 33, so this one I'll just use a generic part just for the sake of time. What is it, CP? Yeah. So we can throw our, what they are calling their bulk capacitance, but truth be told, do they not have the little junction? There you go. A 10 microfarad ceramic would still be considered a bulk capacitor. Why in the world is that so painful? Alright, electrolytic goes there. And then we can just manually set the value to 33 mics. So now we have our input caps that they want. And now for the LTZ combination, yeah, not sure. So now we need a cap for the LDO, and I didn't check, but I'm pretty sure it's what I yeah, there's definitely a bug here. Like, it automatically keeps my pointer to where it last was. So that's what was happening with the label. Now I can just see it, which is a kind of a pain. It's probably fixed on the latest nightly. I think this one is like a month. Okay, how do I actually place it though? So maybe I click it and then exit out. Now I move it. Yeah, I guess that works. Okay, one mic. here, LDO. Now Fset is for the frequency. Again, I would do the calculations and see what is recommended, or what value you want. Obviously, not obviously, but the higher the frequency, you can get a much small. Oh, that's why I wasn't even thinking. They're running this at 400 kilohertz. That's why the inductor's fairly large. Let me change this. 33. I meant to take 33. The higher the switching speed, the smaller your inductor will be, the more EMI you'll have because it's a higher frequency, but the lower the efficiency will be. So 33 mic is pretty big, so I would probably bump up the frequency a little bit. For their frequency set, they're using 160 kiloohms. Yeah, that is really weird how it does that. It forces my pointer to that. So this is another value I don't think I have. Nope. So we'll just use a generic resistor. And that's one thing I'm actually working on is a Python program that'll download the whatever screen you have exported from DigiKey, and will add all of them into the library. I doubt it'll be useful for many people because it'll be based on how we do our library system, but you never know. So that is what sets our frequency, our switching speed of the boost. The sync pin, so a sync pin, I would assume, synchronizes multiple switchers to make sure that they're on the same frequency. Oh, hey, Eric, glad you made it. I am assuming that's what it is, because if you have a bunch of these, it's like the spread spectrum, like I was mentioning. If you have a bunch of them on the same, yeah, synchronizing DC. Okay, so disable tied to VDIO. So basically, if you, and I'm gonna switch these two to make them next to each other. If you have, say, like 4 of these on a single board because you're driving 4 displays or you're driving whatever, you can either have all of the bucks driving at the exact same frequency peaks like you would use with the sync pin, which the advantage of that is now you have all of your EMI peaks at the exact same frequency at the exact same time, so they will build on each other. And that sounds bad, but the advantage is your filter will be for those peaks specifically, where if they are not on the same spectrum, you'll get that spread, which is a lot harder to filter, which is why the fact that this does the spread spectrum where it adjusts the frequency, I don't really like it because it makes it that much harder to design filters for. But if you're not doing a filter, it is absolutely better. So that's probably what their thinking is. And so now did it not update? Oh, I updated the local part on this and not the library earlier. That's why it updated the feedback pin. Okay, that makes a lot more sense. A whole lot more sense. Okay, so it's now exactly like how PCB new is. Got it. So that means... But now how do you... Oh, so you have to go to edit library signal. Got it. That makes a ton of sense. So now, yes, sync is here. But now how do you update it? Update symbol. Okay, so it's exactly like PCB new now. Okay, so then on this one, when I moved the feedback, it was only for the local part. Got it. Okay, that makes sense. Cursor gets locked, D, schema, canvas. So there's the bug. Yeah, I'm honestly kind of shocked that that has stayed in here as much as it has. considering that that's kind of like a big deal. It makes it almost unusable. Okay, so sync and VDDIO. VDDIO, the assumption here is that's for the logic level for the LDO. So I guess I better check before I assume. VDDIO enable for the input and supply voltage, so it can be used together. So yeah, we'll just tie that to 5 volts. God, that is really annoying. Okay, there you go. Why am I doing a label? It should be a... Oh my gosh. Yeah, I really hope that they fix this, because that honestly makes it almost unusable. That's a really big deal. Okay, so those are tied now. Our PWM for backlight, so we can do backlight PWM, and of course it's placed over here. And we're now getting into the other area, so let's move all this. That give us more room. Okay, I guess this is another bug. It's not letting me terminate on the label. Yeah, I'm kind of shocked that I'm finding this many, and I've only used this for what, an hour and a half. Now the fault pin, maybe I'll change, but I don't see a need to monitor that. So let's see if we can just keep it floating, or we have to pull it up. If unused, it can be left floating. Fantastic. Okay, so the input side is set. So this will be at, what was it? I think 400 kilohertz. 400 kilohertz. So now on the output side, I know we need to have our same caps. So we'll move them here, and then it goes through a sync diode. I'm assuming they're using a Schottky. Yes. So let's see. Key. 1 amp, 5 amp. Probably using SMA, and of course it's over here. Yeah, but it's not just labels. It does it with everything. So I think it's what you first said, potentially. It's closed, so it should be fixed. Okay, so yeah, I'll make sure to update my nightly build. Okay, so now we have our sync diode, all of our capacitance, and oops. And for this, what I like to do is have our again, what they're calling bulk, but basically all that matters is our damped capacitance on the farther out side from where the noise is generated. Of course, oh gosh, of course they're all on the same net, so it doesn't matter where you put them, but it's how it'll be in the layout. So for here, like I said before, I will throw in another one just to help with some of the high frequency noise. And if you really wanted to, you could have a pi filter, so a CLC filter after this to filter what's remaining of the switching noise. That totally depends where this voltage is going. If this was in a product for me that I was going to be selling, technically that switching noise that's coming off of the output here is going to the diodes. But that is just sourced. Yeah. The positive leg obviously is going to be going across here. So it will be leaving the board. So any amount of that noise will get coupled across this cable. Obviously, we're talking about an inch-long cable, so it's not going to be crazy noisy. But the fact that it does leave the board, I would absolutely put a filter on here. If it was just on board, I probably wouldn't bother. But that's that. that's kind of up to what you need certification wise. Okay, so now this will be our anode side. Let's keep our nomenclature the same. Backlight anode. And where'd my label go? Back here. What I don't get is, like, where does it pick? Like, why is that the spot it puts it? It's not like the last thing I had selected. I don't really understand that. So this is our backlight anode because it goes here and then syncs it. So we will want to put, oh gosh, wrong button. So here on out 1 and 2, so why is this out 4 and ground? I want to see that. It needs to be connected to ground if not used. Got it. Oh, because I have the 3 output version, so that's actually required. Makes sense. So out 3 gets a non-connect, and now these go to ground, which I am probably going to run out of room here, and we'll have to redraw it, but this works for now. And like I always say, doing layouts, schematics are kind of the same. When you first do it, when you first do like a layout, it's going to look probably like crap. And it's just the more you kind of fine tune, and that's really annoying too. I don't know if it's necessarily a bug, but that's something that KiCad 5 handles. Once you overwrite, it should get rid of the connections here and connect it up above. It does it on one of them, but not all of them. I hope that's a bug because that's another really annoying thing. Okay, so we've got, now go back to our reference design. And like I mentioned a lot, if the reference design is there, you don't have to base your design directly off of it because it's usually going to be a lot different, and they tend to not always do the best methodology, but you absolutely should at least use it as a reference. If not, you're kind of reinventing the wheel. At least I always do. So let's do, what is back BL? We can do backlight instead of doing the full thing. Backlight C1 for out 1. And then, oh, insert also works with little traces now. That's kind of cool. I mean, to be fair, I would have rathered it worked with the backlight, but I guess it is what it is. So that's backlight cathode 2. Try tab when moving the items. Okay, so tab. When do I hit tab? Is it after I move it I hit tab? I am not seeing that do anything. Let me know what you're referring to, please. Backlight anode. So basically now on our, where's the, so basically for our backlight, we will have our common anode here, and then we will sync, and it shows them tied together. That's not true. On the touch screen, it has a separate pin for each cathode, which is why I said I had to confirm with their support engineer, because with it, how it's drawn now, one, you can't drive LEDs like that because the current won't get split evenly, and I didn't know what the 100 milliamps referred to, so basically this should show it separate. So on our switcher, we will have the common anode on the anode here, and then we will sync it on BLC1 and BLC2. People always use K for cathode. I don't like doing that because I get they do it because of capacitor, but I never have seen where they would overlap. And cathode starts with a C, so I like spelling it with a C. Okay, so now feedback. That I will look up actually in the main data sheet because I'm curious what values they're actually doing there. Current LED, we can just use what they're using because it's 100 per strand, but I do not know, feedback. Okay. Using two dividers should be chosen based. Oh, so it sets what the output is boosted to. V boost will be in the range. Okay. So you set what the range will be, but the range as it's set can be set between 8 and 37. Why would that not just be like default? That's a really wide range. So let me see what they say in their reference, what they're doing for the feedback. They don't even mention it. Fantastic. So I guess they're just assuming 20 volts maximum. I don't really want to get in the weeds with that, so we'll just keep them generic for now and then update it at a later time. God, that is so annoying. Okay, so this we're gonna have to move over here. Those just move here. Yeah, it is weird how you can just click and drag it. That's so much different than how it used to be. So here, this would tie to ground, obviously. And actually, let's move this up so the junction will be where the other is. And then feedback here. So this is what sets the... I honestly, I'll need to look into it more. That doesn't make sense to me because typically based on the current set resistor here, it is going to boost the voltage to whatever is required to sink that amount of current. The fact that you set it explicitly, at least with a range, is a little odd to me. I'm sure I'm missing something just because, again, I haven't pre-looked at this part and I haven't used it in the past. So, okay, so we have our 5 volts coming in. We have our bulk capacitance and a high frequency cap here. Our frequency is set with this resistor to 400K. It's not actually going to be exactly 400K. It will spread it out. I don't want to look up how much, but it'll spread it over a certain frequency range to cut down on the EMI peaks. Our sync pin we are not using because we're only going to have one converter. PWM is how bright we want this to be. Our I set pin sets what our nominal current is, nominal or maximum. So if PWM is, I don't know if theirs is floating or just high, that's what our current will be. And on the output side, we have obviously our inductor, which gets switched by the internal FET. We have our blocking diode here, and then our feedback, which again sets the voltage somehow for some reason, and then our bulk capacitance here, which then goes to our anode, and then this goes on to our touch screen and syncs on the 2 cathode pins. So for this, we can do in another hierarchical sheet. Let me see if I can make the sheet. Okay. Well, that kind of sucks. So it's gonna make. Let me restart and see, because it wasn't doing that at the start. Okay, let's try another sheet. There we go. So yeah, it seems like restarting it seems to help a little bit. So this we will do boost LCD driver, and then this can be Did I do... Yeah, that'll just override it. Did I do this with caps? Yes, so I guess I'll keep caps for the file, just to keep it consistent. So we do LCD driver, and then that should overwrite. Hopefully it's not just making a crap ton of duplicates. Probably is, but we can edit that later. So now we throw it in here. So now again, what is important to pass to the outside world? Well, we need to give it our 5 volts in. We need to give it ground, and we need to get our anode and cathode output and our cathode sink. So that is what we will add to our hierarchical pins. And obviously, I could have started doing this with a hierarchical sheet, and I guess it saves time because now I wouldn't have to go back and do it. But I don't know why. I've always just done it outside first and then switch it in. Just because I kind of can know where everything's going to go a little bit easier. See, I remembered to do the insert trick there. Now ground, get rid of, oh, and we also need to expose our PWM. Now we have VIN, and yeah, I could do VDD also, but I usually just do what the schematic says, and that's kind of a rule for me on hierarchical sheets because, again, my goal is to be able to look at the top level without having to click in it, and if you were using, like, say VDD here and then something else for this VDDIO, you really wouldn't know which one you're referring to. So I guess, to be fair, in the nature of what I just said, this should be VDIO as well, even though they're tied together. And now we do, nope, that's a global label. All right. And ground, and I believe that is it. Okay, so now we have our anode, which gets sourced to our diodes, and the backlight gets sunk to our 2 outs. We give it power on the main driver with VIN. We give it supplementary power on the VDIO. On here, we have our backlight PWM pin, and then we source ground. So now let's add all of our labels. So anode is an output, so it'll be on this side. Our VNN is here. We will sync it on the cathodes. And we have our VDIO, and then that's an input. So on the left, and then ground can go here. And then, man, this is like the greatest thing ever now that we can drag these. Oh, there you go. So I'm guessing we can just shrink this, and maybe we can, oh, and we can shrink it from the top and bottom. Oh gosh. Okay, so it does not like being shrunk if there's a pin in the way, which I guess doesn't matter. Why are power nets not connected when you place them down? What do you mean? Which power nets? Are you talking the hierarchical sheet? The hierarchical sheet ones? Okay, so backlight, I guess we can throw here. VDD and VIN go over here, and we can add a little bit of separation, our inputs here, and then we can sync those. Now let's do the same thing that we did before. So 3.81, which is the next multiple above 2.54. Bold it, and that is very large. So maybe let's do 2.54 for this one, and then put it in here. BL anode when placing power ports. Yeah, but if it's connected to the same 5 volt, it would be on the same net, unless I'm still not following you. So here would be now our backlight if we're keeping the same nomenclature, and you can just name it brightness. I hate to keep repeating myself, but with the hierarchical sheets again, since my goal is to be able to read the top level without ever having to click in here if you're trying to find the logic or from a programming side, all of these pins that are broken out are one-to-one with what are in... Oh, never mind. They should be. So this should be PWM, and this should be out 1, and this should be out 2, and this should be... That one is tied to something else, so this, I guess we can do V out is probably the most generic on the power port symbols. Are you doing a power flag to make sure that KiCad knows that it is a power symbol, or at least that it's sourcing power? Okay, so now let's get rid of... Can we update? Clean up. Oh, so just got rid of all of that. Okay, I guess that works. So now... So out 1 is where we're syncing. Out 2 is where we're syncing. V out is where we're sourcing. PWM is here. So now what I said is true. Now you can look at this and know which pins are which if you click in here, or if you're, if you're looking at the top level, you know which pins go where, and now you use a human readable name, which shows you, oh, you can drag that. Go figure. Okay, so now let's wrap up this one. So our VN is going to be 5 volts. For VDDIO, ground is obviously just... Definitely a lot to get used to with KiCad 6, but assuming they fix the bugs that I'm running into, which, I mean, is obviously what they're waiting on before releasing it, so they will. I'm pretty excited about it. So now these we can wait on, because the other thing that I kind of try to do, it doesn't always work, with the hierarchical sheets is using labels as little as possible and just directing straight across to, again, make it easier to see where everything goes. So we have our LED driver that will drive our backlight, and then we will need to do our input power filter, our power linear regulator to drop down to our 3v3, and then work on the touch screen. So I don't think I'm going to go into any other block here, just because I am trying to wrap this up at 7 or 7 my time, which is 7 minutes from now. So I don't want to get halfway through something and have to stop. But with the extra time, if anyone has any questions with this, any questions in general, let me know. And again, plug for Discord. Check the description for the invite. We are getting pretty high on members. I think we're up to like 200-ish, which is crazy. A lot of stuff goes on there. I'm pretty proud of how that's been coming. And shout out to Daniel for taking over and actually making it look like an actual Discord server. If it would have been up to me, it would have been like 4 channels with nothing else for probably all of eternity. And then another thing, I guess, for this project, because obviously doing it all on a live stream, just because making the parts, everything takes a crap ton of time, more than I was expecting. I was hoping to get significantly farther in this stream. Would you guys rather maybe do some streams and some videos for this project, or would you rather maybe me just do, I don't know, I can try maybe to do a weekly stream to get through these quicker, Let me know your thoughts on that, because if not, it's going to take, I mean, it could take a few months to do something like this, and it's obviously a pretty simple design, and I just don't want it to drag out. And I'm obviously haven't done a lot of live streams, so let me know. No questions? Man, I'm either I'm either killing it on explanations, or nobody really wants to ask anything. Oh, and they have a common mode choke here. Huh. Go figure. Coupled coil. That's interesting. Haven't seen that on a LED driver. Yes, it makes sense though. So no questions, no comments, no concerns. All right. Well then, sweet. So then I hope you guys enjoyed this stream. I guess then just let me know in comments or Discord how you want this project to go, just more streams or combination of streams and videos. And then as always, let me know topics for future videos. Am I drinking coffee at 7 p.m.? I am not. I am drinking water. I do not drink coffee whatsoever. My girlfriend, she drinks coffee pretty much breakfast, lunch, and dinner, but I do not. I like live stream format. Weekly sounds good, but maybe selecting the parts and symbols. Yes, that I think does make a lot of sense. So I think I'll probably plan on doing that, just because nobody wants to watch someone build parts for all that time. Well, sweet. I will see you in the next video. I'll have a video up next Saturday. Maybe do another stream also on Saturday. But I'll post about it on Discord and on YouTube. Well, sweet. I will see you guys in the next video. I had a lot of fun. I will talk to you later.